Okay, this is a histogram of trees and their heights in centimeters. So a histogram shows us both the frequency of something, so how many times something occurred in our data set. So like we actually can determine the number of trees in each range. And then it gives you these bins. So each bar on a histogram communicates a range of, in this case, heights. So this first bin has a bin width of 50 centimeters. So all of the trees that are greater than or equal to 100 centimeters tall, but less than 150. So in between 100 and 150. So our height. So this bin, this first bin, communicates the number of trees that have a height that is greater than or equal to 100, so including 100, but less than 150. So our x-axis is our height. And the y-axis is our frequency. The frequency is again, the number of times it occurs in the data set. So this looks to be about 4. So what this bin in our histogram is communicating is there are 4 trees that have a height somewhere between 100 and 150. So we don't know if the heights are 100, 120, 130, 140. We don't know. It could be 100, 100, 100, 148. It could be 100, 110, 120, or 130. Our height could be 140, 140, 140, and 140. We have no idea. It could be including 100 or not including 100. It could be 120, 135, 140, and 149. But it can't be equal to 150 centimeters. Because once your height hits 150 centimeters, now it moves to the second bin. So this second bin is the heights of trees that are in between 150, but less 150 and 200. So greater than or equal to 150, but less than 200. So there's 30 trees that have a height between 150 and 200. So there's 4 trees in this bin, 30 trees in this bin. In between 200 and 250, so greater than or equal to 200 centimeters, but less than 250 centimeters, there's, we'll say that's 25 trees. Then greater than or equal to 250, but less than or equal to 300, that's 50 trees. And then finally, our last bin is the trees that are greater than or equal to 300, but less than 350. That's a little bit over 10. So let's say there's 11 trees. So a histogram can tell us how many total trees are in our sample space. How many trees were measured? So 4 plus 30 plus 25 plus 50 plus 11 is, we have a total of 120 trees that were measured. So a histogram is different than a box plot. Here's an example of a box plot. Here's an example of a box plot. We know that based on this box plot, we know the smallest tree in our sample was 100 centimeters, and we know the tallest tree was 350, and then we know that 25% of the trees that we measured were in between 100 and 130. 25% of the trees were in between 130 and 160. 25% of the trees are in between 160 and 200, and 25% of the trees are in between 200 and 350. So what we don't know based on our box plot is we don't know exactly how many trees are in this first quarter. We know that that's 25% of my data, but there could be 4 trees, there could be 50 trees, there could be, I could have surveyed 200 trees, I could have surveyed a total of 1,000 trees, I could have surveyed 8 trees, I could have measured 4 trees, and there's 1 tree in each, right, for all we know. But I do know a couple things. I know that there is, for sure, a tree that has a height of 100 centimeters. There is a tree. Our minimum, that's the smallest piece of data in the data set, our minimum is 100. I can say for a fact, there is a tree that I measured that has a height of 100 centimeters. And I know for a fact that there's a tree that has a height of 350 centimeters. Those 2 things I know for sure based on this box plot. Looking at my histogram, I do not know that there is a tree that has a height of 100 centimeters. I don't know what my minimum is. My smallest tree, my shortest tree, could be anywhere in between 100 and 149.99999. Right? I could have 4 trees that are all 149, 149, 149, 149, technically. So I don't actually know the heights of those specific 4 trees. I just know that there are 4 trees in my sample that had heights somewhere between 100 and 150. So on a box plot, I can know the min and the max for sure. But on a histogram, I do not know for sure if I have, I can't specifically identify the min and the max. I know that it's somewhere in that range, but I don't know for sure. So if I know the total number of trees in my sample, if I know that I measured 120 trees, that can help me identify-ish where the median is. So the median is the middle of our data. So if we've surveyed 120 trees, that means that wherever our median is, half the trees are going to be shorter than the median, and half the trees are going to be taller than the median. So there are 60 trees that are shorter than the median, and there are going to be 60 trees that are taller than the median. So I am going to go figure out which bin is the 61st tree, because my median is going to be in between the 60th and the 61st tree. Okay, so there's 4 trees in the first bin, 30 trees in the second bin, and 25 trees in the third bin. 4 plus 30 plus 25 is 59. So I know that 59 of my trees are in these 3 bins. So that means that tree number 60 and tree number 61 are in this bin, because the next 50 trees are in this 4th bin. They have heights between 250 and 300. So my median is somewhere between 250 and 300. My median is going to be greater than or equal to 250, but less than 300, because I know the 60th tree is at least 250 centimeters tall, but no more than 300. And I know the 61st tree is also in between 250 and 300. So my median is somewhere in this bin. So a histogram allows you to know how many data points are in each bin, which allows you to know the total number of data points, which allows you to identify which term would be the median, or if it's like an even number, our median is between 2 of our terms. And so if you can identify which bin those terms are in, it'll help you identify where your median is.